Very good afternoon, fellow Foundrymen. It gives me immense pleasure in interacting with you all for the 19th technical webinar for the year 2022-23 conducted by the Institute of Indian Foundrymen, Chennai chapter, online through Microsoft Teams. To get things started, we now request our Chennai chapter Vice Chairman, Mr. V.K. Raman, to welcome the gathering, please.
Yeah, thank you, Vignesh.
Yes, sir.
Am I audible?
Yes, sir, you're audible, sir.
Okay. Welcome, Kumar sir. Again.
Yeah. Yes, sir. Welcome. Thank you.
Thank you. So very happy to note that today we are going to talk about the roadmap for 0 ppm. So which is a fundamental requirement for foundry processes. In any foundry, we can achieve production numbers, delivery numbers. They are all quite possible. Easily we can achieve, but achieving the rejection and sustaining the rejection trend at the same level or further reduction is a challenging task for any foundry. So we are doing all the methodologies, following all the process controls, implementing all whatever the corrective action we are taking, whatever possible by us. But sustaining such a rejection control or sustaining the reduction is the very key for any foundry to achieve the P&L level and to improve the P&L level of foundries. So to understand and enrich the knowledge, whatever we have, to be further enhanced, whatever the position we are at now. So to enhance the knowledge on achieving the 0 ppm, Mr. Kumar is going to give us a clear-cut roadmap and the steps to be followed to achieve the rejection reduction. So in that connection, I welcome you all for this wonderful webinar and attend the program till the end of the presentation, and you can ask as many questions to Mr. Kumar, where he will be able to give full clarification for any question. So now over to Mr. Vignesh to introduce Mr. Kumar to the forum. Before that, I wish you a very happy Deepavali to all the participants. Thank you. Over to Vignesh.
Vignesh, you are in.
Thank you, Raman, sir.
Okay.
Sir, it gives me immense pleasure in introducing our speaker for the afternoon, Mr. R.S. Kumar. Kumar sir is a B Metallurgical from GCE Salem, has over 23 years of service in Southern Auto engine components, Gumadipundi, a 1,000-ton foundry in India, Gumadipundi. Worked in various capacities from GET to plant head, visited most of the OEM customers and foundries in India and abroad. Active member in Rotary, IIF, S2S, passionate in leadership, guest speaker in leadership and technical conferences, married and blessed with 2 boys. It is our pleasure to have Kumar sir with us here today. Sir, Kumar sir, the floor is yours.
Okay. Yeah, happy afternoon.
Happy afternoon, sir.
Yeah. So we will start with the puzzle. So anybody can connect all the 9 dots with the 4 straight line? Any answer from the listeners?
Sir, participants can unmute yourself and answer if possible. Yes.
Yeah, repeat the question.
So we need to connect all the 9 dots with only 4 straight lines. 4 straight lines.
One straight line is from one dot to another dot, sir, like that.
4 straight lines allowed is 4 straight line, and it should not be the pen should not be removed. It should be continuous.
Ah.
That is the condition.
Sir, is this possible? First, we have to get the diagonal line.
Yeah, anybody can show if you have done.
சொல்லுங்க ஹேமபிரசாத் சார்.
Sir, actually, the line, the first 3 dots will be in diagonal. That it will be extended, and we have to.
If you have done something, you can show it in the screen so that everybody
Okay,
can
one
see.
second, sir. One second. Is it possible to show? It is possible to see?
Okay. Show it correctly, yes, sir. So
Yes,
the
yes.
center of
Yes.
yeah, yes, sir. Can you show?
சார் நல்ல கேமரா பக்கத்துல காமிங்க ஹேமபிரசாத் சார்.
1 second. It's very small. I'll put it in bigger way.
Yes, sir.
Okay, sir. Thank you.
கரெக்டா குமார் சார்?
இன்னும் கொஞ்சம் காமிங்க சார்.
ஃபர்ஸ்ட் டயகனலா போயிடுறாரு, அதுக்கப்புறம் அப்படியே ஃபுல்லா கவர் பண்ணிடுறாரு.
அது அந்த diagonal கொஞ்சம் எக்ஸ்டென்ஷன் வரணும் கீழ.
That is right. Extension. Okay. Correct. That is right.
Thank you.
So you see the screen now?
Yeah, it's visible sir. நீங்க இதுல போயிடுங்க.
Yes, it is
Slide show
visible.
mode. Yeah.
So you can see the line how we are doing. So you see?
Great sir.
So it's like a kite.
So the idea is we need to think, we need to expand our definition. So if it is within the box, it is very difficult to find the answer. So we need to think the possibilities how we can make it. The frame, what we have, we need to think out of box. That is the idea, putting this puzzle in this there. And the topic is very well chosen by the chairman, and he asked me to present this idea to the people, Foundry people. So I have taken the challenge to give some valuable input so that we can prosper in the profitability. So it is a very good data also. So we can go with from 22, 10, 22, and the reverse directions also coming the same 22, 10, 22. So we need to define the process to get the right process to get the right quality. So these are the companies, how the companies fail. So you can see Toyota to close plant for first time, and Sony slides into a slump. South Korea set to dismantle financially troubled Daewoo, Hyundai teetering on brink of failure. So these are the. Hello? The screen is visible?
Yeah, it's visible sir, visible.
Yes,
Sir,
sir,
right.
visible.
Yeah. Sir,
Yeah,
please,
these are the
all the participants requesting you to not unmute, please. It's disturbing the program.
Yeah, these
Please
are
go
the failures of the companies, and we cannot survive unless we change the direction. So this is the idea from these slide, these news. So we need to change our direction. So coming into the picture of zero defect, the total quality management, that is the TQM, is the way we can move forward. And as per the total quality, customer focus is first, quality first, fact-based decision making, PDCA, that is plan to check act, prevention, that is avoid recurrence, people, we need to respect people, train, retrain, process focus rather than result. So we need to focus on the process. So these are the points we need to focus. So the customer wants world-class quality. So they want 0 ppm, no doubt. So to achieve that, we should have a condition that we do not procure the raw material or the input material, or we cannot procure, we don't produce or we cannot produce, we don't pass or we cannot pass defectives. These are the conditions we need to set in our process. Each and every process, the micro level process, we need to set the conditions not to generate defect. So it should be, quality should be proactive and preventive. So we need to focus on precise and accurate all the time and every time. So in that proactive and preventive technical reviews, it should be robust and cross-functional. Specifications, we should not assume. We need to understand. PPAR, focus on process, controls through SPC, POCA, in process change management, seamless communication, fix it through 80, Six Sigma, so many 7 QC tools. So these tools we need to use it to fix the problem. FMEA, it should be a live document. It should not be the audit purpose, or it should not be kept in the engineering or the quality department. Inspection aligned with the customer, aesthetic established with the master sample. So this is our last presentation. Also, I showed this presentation that is 85% of the reasons for failure to meet customer requirements are related to deficiencies in systems and processes rather than the employee. The role of management is to change the process rather than badgering individuals to do better. That is the Deming statement. So the purpose of the training is to influence the way we think, what we do, and the result. So the barriers in learning, as I already know this is not applicable to me. Things will not change at my department. I don't have any benefit from this. Classroom learnings cannot be practically applied. So these are the barriers, and we need to come out of the situation. We need to focus for the learnings, new things. So the people do what people see, or the people can do what they know. They cannot do other than the limitation. So ultimately, we need to open our mind, learn many things. So which is already there now. The informations are on the Google. Everything we can get it immediately. So we need to open our mind to learn something new. And maybe each and every day we need to focus on the learning. How to work, look at environment and identify CTQ, that is critical to quality, find the gap, current and target, convert the gap into project and collect data, generate report, visualize the situation and make meaningful conclusion. Hurdles to quality improvement. Many companies and managers take refuge in one or more of the following beliefs. To err is human. Excessive quality costs too much. Takes too long. Just beating last year's number is good enough. We are still better than our competitors. So this is the hurdles. So long back, the Philip Crossby told that quality is free. It is that means first time when we make the castings, getting 100% okay, there is no extra cost all involved. That is so. In that background, he said quality is free, and he wrote a book with the name "Quality is Free." It is available in the market. He was a technical director, one of the companies in America. Continuation, unreliable processes and systems, indiscriminate cost cutting that lead to sacrificed quality, obsession with short-term results including profits, market share, costs, budgets, and schedules. Unempowered, poorly motivated, and paid personnel are disregarded for their ideas and suggestions. Centralized and bureaucratic decision making, emphasis on correction and inspection rather than preventive and proactive approach. The inspection cannot stop the defect. So our ultimate idea is to prevent the defect in the process. Error of quality comes from inspection, old age. Quality is from management. That is the new age. Quality means doing it right when no one is looking. Henry Ford. It's a famous quote from Henry Ford. Employees, quality cannot be achieved only through technology, products, and processes. It needs involvement of flexible, motivated, competent employees who are continually seeking for better way. If a company has employees that don't have adequate knowledge, skills, they will have trouble in understanding directions or are misinformed. Quality may be severely diminished. Quality system problems due to no system in place, no communication, system not suitable, system not effective. So organization culture, fire prevention, database decision, 5S, accepting mistake and identifying its causes, adherence to SOP, Gemba working, process focus, long-term benefits, waste reduction. So basic few terms: correction, corrective action impact, preventive action, type of root causes. So these are as a IATF or ISO companies we know very well, so I don't want to go in detail. So the variation is coming, the reason for the defects are the variation, and the variation is again classified into 4, that is forum, we call it as forum, man or human, machine, material, and method. So these are called forum, and the forum changes are the main causes for the defects. So man, is operator trained, operator level, is operator under training, is operator temporary for stage. So these are the questions, and we need to have a concrete plan to train the man. So many of the time we have heard that because of the new manpower, rejection is high or production is low. So that is the reason people are telling every meeting we have heard lot of times the reason. So this we need to say that this is not the cause. So the man should not be the cause for the failure. So such a way we need to frame, identify the conditions. What are the conditions we should have, and we should have all the checks to be verified. Machine is a specified line used. So now if we have 2-3 lines, we will put first line, second line, third line, any line we may go, and we don't know which line is giving problem. So the line we need to have, and we need to follow as per the line which is established. Last calibration if required, good condition, is alternate machine used, or machine parameters known, parameters are respected. Material, is the specified product used, did it evolve or change? First in, first out followed with the proper traceability. Is the shelf life expiry date respected? So we need to have the conditions or the raw material specification, and we should have the conformance of the raw material. We should not say that this material is not correct, so we are having the problem. So whatever the controls we should have in the previous processes. So we should not allow the bad raw material to come into the production. Method, is main steps are respected? Is there are related key point in work instruction? Are the reasons for the key points known? Are operating requirements respected? Is the defect part of the checkman list? Was it detected by checkman? So these are the questions, and there should be answer in the operating procedure, standard operating procedure or work instruction. So we need to respect the set process. So violation is not allowed. We should be hard in the process. We should not allow the deviation. So product, is it in one shift? Is it in one line? Is it a repeat problem? So these data we should have. We should collect the information, and based on the information we need to act. The environment, is there a monitoring plan? Is it implemented? Does it conform? Is the packaging in good condition? last preventive measure taken on? Is there any alert mechanisms? So these are the variation conditions. And how to improve operator mistakes? One is the standardization. We should have visual control, POCA, that is fail-safing or mistake proofing, skill enhancement, automation, simplification, audits, job rotation. So these are the ways to have checks. How to fix the causes? Is there any specification? If it is there, if yes, what is the specification? So the specification is satisfying the quality requirements. If it is not there, then we need to have a process capability, and we need to adjust the specification. If it is a customer specification, we cannot do anything. We need to meet the customer specification. In the process, we can adjust what will be the input process conditions to meet the capability, and a higher capability or the higher PPM. We can select based on the statistical process control. What is the basis, standard, or DOE, design of experiments? Is it checked? How? And the frequency. Is there any difference? If there is a difference, we need to take action, and also the controls. Action plan, responsibility, target date, status. So regarding the defections, system-based reasons are 95% and human-based reasons are 5%. So system-oriented, the process would be from system-oriented, not man-oriented, not dependent on the man. If the firms improve their systems and implement prevention systems, the system will not allow the employees to fail. That is Deming 1986. So now coming to the zero defect concept. To maintain integrity of quality, that is a set of 100% non-defectives. Condition setting. Set conditions for zero defects aimed at equipment and processes that don't produce quality defects. Daily and periodical inspections. Inspect and measure condition in time series. Quality preventive maintenance. Prevent quality defects by maintaining measured values within the standard. Trend control and predictive maintenance. Predict possibilities of quality defects occurring by observing trends of measured values. Prior countermeasures. Take measures beforehand. So the past history and the countermeasures we need to consider. So implementation procedure for quality maintenance. Understanding quality defect phenomena. That is the mechanism of defect mechanism we should understand. Setting of standard values for inspection items and confirmation of results. Concentration of inspection items and shortening of inspection time. Drafting of quality maintenance matrix. So implementation procedure, quality maintenance continued. Master plan for quality maintenance. It has a 3M or 4M analysis. PM, the defect phenomena. So that is the phenomena mechanism analysis for exposure and handling of malfunction. The PM is not preventive maintenance, it is physical phenomena mechanism. Kaizens and POCA for eliminating defects. Maintaining zero defect. Process capability improvement plan. Understanding quality defect phenomena. Clarity on the definition of the defect, whether it is sand drop or blowhole. If it is a blowhole, there are different categories like a hydrogen blowhole or nitrogen blowhole. So we need to identify it is a carbon monoxide blowhole. So the definition should be clear. Frequency of occurrence and effect of defects. Setting of standard values for inspection items and confirmation of results. If standard values are set for individual inspection items and equipment precision is maintained within the standard range, it is necessary to confirm that all quality characteristics can be satisfied. If they cannot, the cause is either that there are omission in inspection items or standard values are not stringent enough. In either case, it is necessary to return to PM analysis and carry out study. So nowadays, in our foundry on day-to-day basis, the rejection is sometimes going from 1 or 2% to 10%, 15%, and as an average, some foundries may get 2-3%, and some foundries 10%, 15%. So the rejection is going each day there is a variance, and each product with variation. Each product, some product may have 2-3%, some product have 10-15%. So those things we need to go and monitor the conditions. So what are the forum conditions? How we can able to improve? Concentration of inspection items and shortening of inspection time. For orderly implementation of condition control, review inspection items themselves and satisfy the following condition. Reducing inspection items by concentrating on the number of items for inspection. Extending inspection interval by eliminating forced machine deterioration. Shortening inspection time by taking steps for difficult to inspect spots. So this is basically we can understand from Pareto principle where we need to focus. So we need to focus on the vital few elements, which is 20% of the parts will have 80% of the problem or the percentage of rejection. So we need to choose the vital few items and focus more, identify the variations, and we should have the action plan to improve. If inspection items are many, inspection intervals are short, or inspection requires much time, maintenance and control will become difficult, and eventually achievement level will decline. Elimination of forced deterioration and spots that are difficult to inspect depends greatly on Sisukosan implementation. That is the Gemba. It is a Japanese word, so it is Gemba quality maintenance. Drafting of quality maintenance matrix and reflection in standards. So quality assurance matrix is prepared to establish the relationship between defect mode, and the process which causes it. It requires data collection for defects at various process stages to prepare a quality assurance matrix. So this is the foundry, the typical case. One side is the defects, and we have the molding, core making, melting, fettling, everything. So these are the quality matrix. So which is causing the defect. So like that, if we have on the right side, we have the numbers. So number of for the blowhole, the number of causes are 10, and also it is given which is least and which is having higher variability. So quality maintenance master plan. The master plan for quality maintenance is planning of various activities in this pillar with respect to the time frame in months and years. According to the stage of TPM implementation, it can start at various levels. In the beginning, it will start with the data collection of defects to improving conditions to sustaining zero defect conditions. So 3M or forum analysis. This analysis is a set of conditions with respect to machine, material, and method for obtaining a good products. It helps in identifying 3M standards and checking is possible against these standards. Removing this variability can sometimes eliminate quality defects in the product. So this is a machine, material, method. So you can see the defect is blister. So what is the method? Machine, material. So what are all the causes? So it is given. So like that, we need to identify the conditions, and we need to see whether it is satisfied or it is not meeting. If it is not meeting, we need to improve the process. So execution of the physical phenomena mechanism analysis for exposure and handling of malfunctions. The PM analysis is one of the most effective techniques to handle it as a B, C type of problems. So PM denotes a physical phenomena mechanism. In this analysis, we try to establish the relationship between phenomena and the physical mechanism behind it, which explain the contributing conditions to cause such physical mechanisms. These contributing conditions are then elaborated in terms of relationship with the primary, that is man, material, machine method condition. Usually these primary conditions are not measurable, so they are once again converted into secondary conditions that can usually be physically inspected against a standard. So it is a continuation. After finding the standards, a survey is performed to see the variability against the standard, and all such conditions are listed as not good. It is advisable to take countermeasures against all these conditions simultaneously so as to eliminate most of the chance causes in the system. This helps achieving zero defects in the product. So coming to the POCA-OK for eliminating defects, the POCA-OK is the defect prevention. So to err is human beings are very forgetful and tend to make mistakes. Many times we end up saying operator carelessness, negligence, or operator inattentiveness. If we carefully look at such processes, we can reason out that these are combination of many factors rather than just operator carelessness. So monotonous, mechanical, and long tense working environment tend to make people commit mistakes. If we bracket these mistakes as carelessness, the people get demotivated and discouraged. POCA-OK is a technique for avoiding simple human errors at work. POCA-OK is a Japanese word meaning inadvertent errors, and yoke comes from Japanese word yokiri meaning to avoid. This has also been termed as mistake, foolproofing, or fail-safing. The idea behind POCA-OK is to free a person's mind from maintaining repetitive vigil, which may be practically infeasible. By doing so, a person without the fear of making mistake can constructively do more value-added activities. So characteristics of fail-safing devices: it is inexpensive, give prompt feedback, focus on prevention. So this is fail-safing examples. Say we have checklist, barcode, safety switches, pull-down menus. So these are some examples. And ABC fix explanation scenario. So the ABC, I will explain what kind of mistake proof is. The problem: automobiles are crossing the train tracks and getting hit by a train. It is called C fix. It is only a warning. Place flashing cross signs at the crossing to alert vehicles. Dilemma: vehicles are alerted of oncoming trains but can still cross. Problem not solved. So this is only a flash or something, some red light. It is only an indication, so people can cross, and we found a lot of accidents. So another one is the B type mistake proof. Place cross gates at crossing to further deter crossing of vehicles. Dilemma: vehicles are alerted and have limited crossing ability. However, doesn't prevent those who arbitrarily want to cross. Problem reduced but not solved. Still people can cross. So the ultimate is A fix. Build overpass for vehicles to cross train tracks without incident. So dilemma none. Problem is solved. So you can see the flyover is above the railway track. So there is no problem of the accident. So this is the ultimate. This is the ultimate preventive action. We need to see maximum prevention like type A fix. So this is a typical warning example in India after the Prime Minister Narendra Modi came to power. So you know, a lot of accident in Guwahati, the elephant accident. So they introduced one bus and honeybees to keep elephants off rail track in Guwahati. So after the implementation of the railway department, the number of the accident, the elephant accident is reduced. So it is a very good example to reduce the accidents. So this is some of the examples, mistake proofing for inventory restocking. So each bin location is barcode verified and has part photo. So that will not allow the other part to come wrong placement of the part and quantity. Barcoding for wrong and missing parts. So this is one of the example. So they have a barcode on the part itself, so they can scan it and understand this is the right part. So errors are inevitable but can be eliminated. People always make mistakes. These can be reduced or even eliminated. Some of the Poka devices which can help avoid defects are guide pins, locators of different sizes, error detection buzzers and alarms, limit switches, proximity and photo sensors, counters, checklist, and even nowadays when we go to engine plants, we can see the trays with all the parts. So at the completion of the assembly operation, they can understand very well all the parts are assembled, or if anything is missing, at the same time they can correct. It cannot go to the customer. It cannot go to the next process. So basic classification of Poka Yoga, as I said, the prediction versus detection, alarm versus shutdown versus control, contact versus fixed value versus motion reading methods. So these are the methods, and I will go through it. These are you may know very well, and each and every foundry we need to work. We need to understand what can be done better. So when a Poka AK is designed in a way that it helps the operator to recognize the defect before it is about to occur, it is called a prevention or prediction type Poka OK. So the prevention is the best method. So it is also called control method. So it cannot allow the defect to happen. So other method is called warning. So it can give after the occurrence. It is only a warning type. It cannot prevent the defect. So that is the warning type. When a Poka OK helps the operator know immediately on the occurrence of the defect, then it is called detection type, Poka OK. Detection is after the defect is produced. The merit of this type of Poka OK is based on the stage at which the defect is detected. In simple language, earlier the better. So some of the prevention mechanism. So you can look at the left hand side. There is only two locations, and now you have additional 4 pins are given so that the wrong loading of the part is not possible. So detection, you know, the bigger size hole and the small size hole. So this is avoided with through a check by using 4 locator pins and a gauge. So these are other type alarm. You know, we have a alarm for the pouring timer, and also everywhere we can every area we have a alarm like the pressure, the molding pressure, and everywhere it is there. So instead of having that alarm, we should have a link to the machine that it has to be interconnected. If it is low, the machine should not start. It is everywhere we can try to apply like the chemical composition, temperature, the shot blast, the arms, molding machine pressure, and also the parameters in the molding sand. So those things we need to connect with the PLC, and we should have a control mechanism that the machine should not start if anything is out of control. Contact versus fixed value and motion reading methods. So these are some of the examples. I will skip So types of sensing devices, say limit switches, micro switches, proximity switches, photoelectric switches, beam sensors, sensors to detect changes in physical condition like temperature, pressure, etc. Pressure switches, thermostats. And these are 8 types of errors. One is the processing errors, including safety errors, assembly errors, inspection errors, processing omissions, assembly omissions, packing, pasting, labeling errors, misorientation, misalignment, and dimensional errors. So maintaining zero defect, there are a lot of activities required to be done for maintaining zero defects. It starts with the following checklist: preparing quality maintenance matrix, preparing checklist for inspection of zero defect conditions, and also audits for monitoring activities related to zero defects. This involves preparing correct operating standards and other standards for maintenance. Process capability improvement plan. Sometimes the capability of a process needs to be enhanced to obtain high capability value for critical characteristics. This plan again follows the analysis for variation in the characteristics and taking countermeasure against all the sources. So one of the example what we have done in our foundry, for example, the process which consists of input and output. So we need to focus more on the variation. That is, we need to focus on the input, not outputs. So we need to focus on the causes. So what are all the input causes, like infrastructure and resources, inspected table, reject and rework bin, eye checking report, the operator, the inspector eye checking report, lighting, lux value, quarantine area, inputs, camshaft, tapered, any castings and inspection plan, document and record like control plan, working second, SOP, car sheet, visual inspection report, customer standard, root card, tag, risk, operation missing, part mix up, handling damage, complaint, that is skipped defect, no awareness about process risk, no awareness of customer standard, untrained, inefficient inspector, that is competency skill related. So these areas we need to focus and we need to find the variation, why we are getting the output variation. So in the output it is OK parts, finished good stock, plan versus actual inspection data, reject and rework data. So focus more on the input variations and try to reduce the variation and close the gap, which is controllable. We can very well reduce the variation over a period of time, and we can improve the outputs. So to identify the gap, these are the supporting standards like CQI 27 for the castings, total quality management, Deming 14 points, cross by 14 programs, world class quality audits from Ford, General Motors, Caterpillar. So they have all have a checklist and we can verify, and there are scores out of 100, how much mark we are getting, and keep on improving the standards so that we can reach 80, 90%. So we can improve our process, and obviously we can reduce the rejections, and also ISO and IATF standards. So this is Deming 14 points. Just I touch upon only the points. The constancy of the purpose, adopt the new philosophy and take on leadership. So it is one of the important point is eliminate inspection, built-in quality. So this is very, very important point we need to look at. So we need to have a built-in quality. So what are all the input condition is going to give me the output zero defect. So we will have the zero rejection at our process. So we need to focus more on the process. Minimize total cost by improving quality of supplies. So here the number of suppliers for one item like bentonite or the sand or the any raw material, if we have 2-3 suppliers, then that much variation is there. Obviously, we will have a lot of variation in the process, and we will have a rejection in the output. So instead of having 2, 3, 4 suppliers for the one product, we can choose one better product and we can continue. And if there is any second source, we need to validate whether it is in line with the current supply, or it should be the better than the current. So like that, we need to choose. Constantly improve quality and productivity and decrease costs. Training on the job. Supervision should be to help people. So drive out the fear. So there should not be a fear. I will send you out if you do like this. Something it should not be there. We need to mutually give input to the people. We should respect the people. Break down barriers. Work as a team. Eliminate slogans. Fix the system. Eliminate quotas. Substitute leadership. Remove barriers to pride of workmanship. Institute a vigorous program of education and self-improvement. So there will be a continuous improvement programs will be there. And the transformation is everybody's job. So we need to transform. Transformation is the key. Change is permanent. So we need to change for the better. So this is the another zero defects 14 programs by cross-buy. So this is these are the fundamental steps given by the cross-buy. Here it is almost in line with the Deming. It is a corrective action plan for zero defects. Supervisor training, zero defects day. That is next month we are going to celebrate the 0 month. So these came from like these principles. So November is going to be the quality month. So we are also last, I think, more than 10 years we are celebrating the quality month. It doesn't mean that it is only this November is quality, but it is we are focusing more improvement points, and we need to continue take actions. So keep on doing this, and the variation will be reduced, and we can improve the performance of the organization. Quality council and repetition, that is the again and again we need to do. So this is one of the roadmap from our company. So total employee involvement, that is a KSAN, QCC, quality control group, and problem solving, that is quality circle. Problem solving, these things we need to involve all the employees. List and eliminate of bad habits. List and elimination of undesirable practices. Safety, 100% awareness of safety among employees. Zero unsafe condition and minimize the risk of unsafe act. 100% use of PPE against unsafe act. Fires, traceability, place for everything in its place. So we should have a place, and that place, the part should be there. Dent, damage-free handling. So most of the foundries I have seen, it is scattered everywhere, and it is thrown from one place to other place. We have defects, and even when we give bins, it is overloaded. Yeah, so the handling is happening. Because of the handling damage, we see damage, some cases 1% or 0.5%, 2%, depending upon the handling. Even loading, unloading is done without any containers. So this is how we handle castings. So container standardization, they see the container should be a standard one, quantity should be same, like that we need to standardize. And lean manufacturing, so there are 8 wastages are there, we need to reduce. We should have a program, and we need to reduce all the wastages, like starting from unused human resources to the transportation, overproduction, inventory, defects. So these kind of defects we need to have a plan to reduce. Quality improvement, So it starts from cause and effect. And in the causes, we have to go YYY analysis. From that, we need to have an activity plan, how to bridge the gap. And we need to monitor the forum conditions for zero defects. And standardization audits, like audits we should plan, the process audit, product audit, layered process audit, and training manuals we need to prepare. And the year, it may be 1 year or 2 year plan. We should work out the plan and implement and see the difference, how it is growing. So when we focus anything, that will definitely there will be a improvement will be there. So I saw one of the vision statement in US Foundry, which was written 1908, maybe 115 years back. The first casting must be good, and they are keeping the statement right. So we have a customer in US. Maybe I visit a couple of times to my customer, and the other foundry is also a supplier to the customer. Last 10 years, there was no visit from that foundry. They supply casting and we supply casting. So I visit almost twice in a year. So there is no visit from the other supplier, and I link to the cross-buy statement that quality is free. That is true. Hope, it has two beautiful daughters. Their names are Anger and Courage. Anger at the way things are, and courage to see that they don't remain as they are. So these are the powerful statement by Augustine. So to address these, we should have a navigation. If we don't change the direction where we are going, we are likely to end up where we are headed. So the lingering questions be: what next? What else? What more? So from these pictures, how to eat the elephant? The answer will be bit by bit. The other right-hand side photograph is a famous sculpture. It is a David sculpture. He is shaping his body, how the stomach should be, or the arm should be, or the face should be, or the head should be. So he is shaping his own image. So like that, we need to shape. We need to have the process, how the process should be. So we need to day by day we need to improve the quality standards. So every road is paved with gold. We need to utilize. So there are quality gurus from Deming, Juran, Ishikawa, Taguchi, Crossby, CGO Singo. So they are all pioneers, and we can have the resources like books are there, or presentations are there. So that's it from my side. Thank you.
Thank you, Kumar sir. Excellent presentation. Very well made presentation, sir. Thank you very much. So, gentlemen, do we have any questions for Kumar sir? Sir, any further questions for Kumar sir? Sir, are there any more questions? Otherwise, we can move ahead with the vote of thanks. So I think we can move ahead with the vote of thanks. So once again, we would like to thank Mr. Kumar sir for taking time and making us rich with knowledge. So, gentlemen, we have today had a very interesting webinar today on roadmap to achieve zero defect TPM. We are sure the contents of the talk had a lot of takeaways for our audience. We would like to thank Mr. S.Kumar, GM Plant Head, SAC Engine Components, for taking time off his busy schedule and for making us rich with knowledge. Further, we would like to thank all the members who joined us for this talk. We are really happy that you joined us today. And I am sure you had a wonderful learning experience, and thank you for joining us on time. We from the Chennai chapter will be conducting many such interesting webinars and programs, and we'll be sharing the same information with you. Looking forward to having you all in our upcoming programs. Thank you very much.
Thank you, sir. I thank Chennai chapter for giving me the opportunities. Thank you. Thank you so much.
Yeah, thank you, sir.
Thank you, Kumar. Thank you,
Thank
Vignesh.
you, thank you, Kumar
Thank you,
sir.
sir.
Thank you.
Thank you, sir. Excellent presentation, sir. Thank you.
Thank you, sir.
Sir, are there any more questions? Otherwise, we can move ahead with the vote of thanks. So I think we can move ahead with the vote of thanks. So once again, we would like to thank Mr. Kumar sir for taking time and making us rich with knowledge. So gentlemen, we have today had a very interesting webinar today on roadmap to achieve zero defect TPM. We are sure the contents of the talk had a lot of takeaways for our audience. We would like to thank Mr. S.Kumar, GM Plant Head, SAC Engine Components, for taking time off his busy schedule and for making us rich with knowledge. Further, we would like to thank all the members who joined us for this talk. We are really happy that you joined us today. And I am sure you had a wonderful learning experience, and thank you for joining us on time. We from the Chennai chapter will be conducting many such interesting webinars and programs, and we'll be sharing the same information with you. Looking forward to having you all in our upcoming programs. Thank you very much.
Thank you, sir. I thank Chennai chapter for giving me the opportunities. Thank you. Thank you so much.
Yeah, thank you, sir.
Thank you, Kumar. Thank you,
Thank
Vignesh.
you, thank you, Kumar
Thank you,
sir.
sir.
Thank you.
Thank you, sir. various